Hello, welcome to my channel. We have been solving these past papers. So right now I have this paper 3 Pure Math 3 and it's 2024, May-June 2024. So we have already solved many of these questions. You can check my previous videos. So right now I'm doing question number 9. Here is it. Okay, so the equation of the two straight lines L1 and L2 are given in this way. Okay, this is interesting that we are given this the equation of a straight line in terms of two vectors. Okay, and in you can see that this position vector of any point on this line is a combination of these two vectors. One is this main vector and the second one is this vector. And lambda is a real number. Okay, so it means if I talk about 2D space, so if this first vector is this vector, okay, and the second vector has a real number multiplier, so it is a vector but its magnitude is controlled. Okay, so it could be anything depending on the value of this lambda. So this is the line I'm talking about. Okay, so you can see that this first vector, which is this one, it gives the position of this line, and the second vector, it gives the orientation of this line. Okay, so this is how we express our line in terms of two vectors and a real number. Anyway, we are given these two straight lines, L1 and L2. Okay, and you see A is a constant which is not known to us, but anyway, we will talk about it in a second. The given thing is that the lines L1 and L2 are perpendicular. Okay, now if I have this is line L1 and this and the line is L2, uh, let me sketch them again. It is not a good idea that I'm sketching. So let's say this is y-axis, x-axis. This is line L1 and this is the line L2. Okay. I will erase this whole thing. Okay. So you can see that if even if I move the location of these L1 and L2 lines, they will still remain perpendicular to each other. Right? It means that their being perpendicular is not depending upon this first vector of both L1 and L2. It only depends upon this second vector, this one, and this one. Okay, so these two vectors must be perpendicular to each other in order to make these two lines L1 and L2 perpendicular. I hope this point is clear. It's very important, but you need to understand this thing. Anyway, so if these two lines are perpendicular, that means these two vectors are perpendicular. And if two vectors are perpendicular, then their dot product is 0. I hope you know this thing, that if I have vector A dot B, it is A into B, mean magnitude of A into magnitude of A into cosine of the angle between them. And if the angle between them is 90 degrees, they're perpendicular to each other. Cosine of 90 is 0, and this whole thing will become 0. Right? Okay, so now I will try to make the dot product of these two vectors, which is going to be 2i minus j plus ak. I have written this vector. Okay, so the dot product of this one with the second vector, which is 3i minus 2j and minus 2k. This must be equal to 0. Okay, I hope this is clear. Now, if the dot product, if you take the dot product, then of course this coefficient of I will multiply with the coefficient of I. So this is 2 times 3 is 6. And then minus 1 times minus 2 is plus 2. And a times minus 2 is minus 2a and it is equal to 0. It means 8 is equal to 2a or a is equal to 4. Okay, so this is my final answer. We have to show that a is equal to 4, so we just prove this. Okay, I hope this is clear. Now, the second part of this question, part B, is that the lines L1 and L2 also intersect. Okay, so they're not only perpendicular, because it is possible that the two lines are perpendicular, but they do not intersect. If you're talking about 3D space, in 2D it cannot be, but in 3D yes. Okay, find the position vector of the point of intersection. Okay, so imagine this is my y-axis, x-axis. I'm taking the example of 2D space. So if I have uh, one vector and the second vector is defining this one, in the same way I have another line of this. This is L1, and there is another line L2, right? And if they're intersecting each other, it means there must be a position vector on L1 and L2 which is same. Okay, so if I try to express my line L1 by a position vector R1, which is given as I minus 2j and plus 3k. Why am I saying 3k? Yes, I'm writing this vector I minus 2j plus 3k. I'm just trying to rewrite this whole thing. Plus 3k uh, plus lambda times the second vector, which is 2i minus j and plus 4k. In the same way, the second line L2 is given by the vector R2, and this is minus I minus j minus k and plus mu times 3i, sorry, 3i minus 2j and minus 2k. And remember, I used this 4, which I found in part A. Anyway, okay, so if these two lines intersect each other, then this, okay, this vector are R1, okay, and these vectors are R2 for the second line. So at some point, R1 and R2 are same, okay, they are same at the point of intersection. And if they are same, of course, I can say this R1 vector is same as R2 at point of intersection. Okay, so that means I can equate these two expression, these two vectors. So I minus 2j plus 3k and plus lambda times 2i minus j and plus 4k. This is equal to the second vector, which is minus I minus j minus k and plus 2 times 3i minus 2j and minus 2k. Okay, so we need to see that for what values of lambda and mu these two expressions are same. So let's collect the like terms. Coefficient of I on the left side is 1 and plus 2 lambda. This is I. In the same way, the coefficient of j is minus 2 and minus lambda. This is times j. And coefficient of k is 3, okay, plus 4 lambda, sorry, 4 lambda, this is into k. On the right side, I have minus 1 plus 3 mu times I, minus 1, which is j, and minus 2 mu times j, and plus minus 1 and minus 2 mu times k. Okay, so if these two are equal, they can see that 1 plus 2 lambda must be equal to minus 1 plus 3 mu. Okay, the coefficient of I must be equal. Okay, so from here you can see that 2 lambda minus 3 mu, okay, is equal to minus 2. Okay, 2 lambda minus 3 mu is equal to minus 2. So I make one equation, one linear equation in lambda and mu. In the same way, if I compare this, the j part, then minus 2 minus lambda must be equal to minus 1 minus 2 mu. So from here you can see that lambda minus 2 mu, lambda is equal to minus 2. Okay, let me make sure if I'm doing things correctly. Minus 2. Mm, no, I made a mistake, I guess. Lambda equal to, yeah. Okay, lambda. Yeah, minus 1 comes here, it becomes plus 1, so minus 1. Yes, sorry. Okay, so yeah. Similarly, if I equate the j part, it is 3 plus 4 lambda. 3 plus 4 lambda is equal to minus 1 minus 2 mu. Okay, into k. So from here, 4 lambda and plus 2 mu is equal to minus 3 and minus 1 minus 4. Okay, just want to confirm. 3 plus 4 lambda. Okay. Okay, so now I have three equations, right? Three linear equations and mu and lambda, and they should give me a unique solution for the values of lambda and mu. So let's try to solve them. Uh, I have, okay. So from this equation, you see lambda equals 2 mu minus 1, right? So if I substitute this value of lambda over here, it is 2 times lambda. So it is this 2 times lambda, which is 2 mu minus 1 minus 3 mu equals minus 2. So from here you can see 4 mu minus 2 minus 3 mu equal to minus 2. So minus 2 cancels and 4 mu minus 3 mu is 1 mu. So mu is equal to 0. Okay, this is one interesting thing, one value we found. Okay, if mu is 0, then you can see that lambda must be equal to, when I put mu equal to 0, so lambda is equal to minus 1. Okay, so we have to see that these values of mu and lambda, they satisfy all these three equations. Okay, so we found these values using these first two equations. So let's see for the third equation. If lambda is 0, okay, and mu is, sorry, if lambda mu is 0, so, and lambda is minus 1, so minus 4 equal to minus 4. Okay, it means these values are correct. Okay, so for these values, both line intersect each other. Okay, but do we need to see find the position vector to point of intersection? Okay, so now I can, if I substitute these values, mu equal to 0 and lambda equal to 1 in any of these r1 and r2, it will give me the point of intersection. Okay, so because that's going to be same, so that's why I can use any one of them. So let me use the first equation. So the position vector r, it is equal to, I put mu equal to 0. So that'll be easier. So I can substitute in the second one. Yes. Okay. So if lambda mu is 0 and lambda is minus 1 or so on, so this is equal to minus I minus j and minus k. So this is the position vector of the point of intersection. Okay, let's confirm this answer. If I substitute in the second one, so this is R2 vector, right? So if I try to find R1 vector, so that R1, I have to put lambda equal to minus 1. Okay, so if lambda is -1, you can see I and -2i. Okay, so you can see 1 and -2 because lambda is -1, so -1 times 2 is -2. So this is I. Okay, similarly, -2 and this is -1, so this will become plus -2 from here, and this will be +1 into j. And lastly, 3 from here, and if lambda is -1, so this will become -4 times k. Okay, and of course this is giving us -I, -2 plus 1 minus j, 3 minus 4 minus k. So both of these position vectors are same. This is same as this one. That means this is the point of intersection of the two straight lines. Okay, I hope this whole mechanism is clear. Now let's move on to the yes, the point A has position vector this. Show that A lies on L1. Okay, okay. So position vector of A. So this means A is a point, right? So OA vector from origin to OA vector, it is given by -5i and plus j and -9k, right? And what was my line L1 again? L1 was R1 and this is equal to, I wrote it here, I minus 2j, I minus 2j plus 3k into, sorry, plus lambda times 2i minus j and plus 4k. Okay. So for some value of I, this position vector will be equal to OA, right? Okay, so let's say if this is equal to -5i plus j and -9k. Okay, so let's see if I try to solve this for the value of lambda. So it is 1 plus 2 lambda times I. Similarly, plus -2 and minus lambda times j plus 3 plus 4 lambda times k equals -5i plus j minus 9k, right? Okay, if this point A lies on the line, then we can find a unique value of lambda which will satisfy this whole equation. So for that particular value of lambda, this whole I will be equal to -5, this whole j will be equal to +1, this whole k will be equal to -9. And if we cannot find the a unique value of lambda this way, that means this point A does not lie on the line L1. So let's see, 1 plus 2 lambda should be equal to -5. Okay, so from here you can see 2 lambda is equal to -6 and lambda equal to -3. Okay, let's check for the next one. -2 minus lambda must be equal to 1. The coefficient of j is right on the left, it should be equal. Okay, so from here you can see lambda, if I take it on the right side, equals -2 minus 1 minus 3. Okay, similarly, the coefficient of k should be equal. So 3 plus 4 lambda, this should be equal to -9. So 4 lambda equals uh, -9 minus 3 is -12. And lambda equal to, if I divide by 4, is -3. So yes, I found a unique value of lambda in, which is for all the cases, which will make the left side equal to right side. That means this point A lies on L1. Okay. So if I substitute L lambda equal to -3 in for this vector R1, it will converge to this OA vector. So that means it is on this position vector. I hope it's clear. Okay. Now this next part is interesting. Um, we know that these two lines L1 and L2, they intersect each other, right? And they're perpendicular to each other as well. Okay. Now A is on L1. This point A is on L1. And the point B is the image of the A after reflection in line L2. So this is L2, sorry. So if I find the image of or reflection of the of A in L2, it will be on the other side of L1, somewhere over here. Make sense? So this is my point B. Okay, B is the reflection of A in the line L2. So it is will be on L1. Okay, find the position vector of B. So we need to find the position vector of B. So we need to find this OB vector. This is what we need to find out, right? Okay, this point, let me call it C, point of intersection of these two lines, all right? So can I find AC vector? I want to find AC vector from here to here, right? So AC vector is OA plus AC. Yeah, this is OC minus OA, right? Okay. Now, we found this point of intersection before, right? Point of intersection was found when when lambda, when mu was 0, right? And we found the point of intersection. It was this one, minus I minus j minus k, right? We found in both these cases it was same thing. Okay, so my this OC vector, right? OC vector is minus I minus j minus k. Does it make sense or no? The point of intersection C, the position vector of C is this one. Okay, minus OA. What was OA? Yes, this is my OA vector. Okay, so let me write it again here. Second A vector life, where did I write it? Yes. Okay, minus 5I minus j and plus 9k. Okay, this was my OA vector. Let me confirm here. Yes, OA vector is given by this one. Okay, very good. So if I simplify it a little bit, you see minus 1 and minus 5. So this is minus 6i. Similarly, minus j and plus j. So it will be 0. Is it correct? I'm trying to find AC vector. Minus I. It is plus j. Sorry, yes, I made a mistake. Plus j. Okay, so minus j and minus j. So this is minus 2j. Similarly, minus k and minus 9k. So this is minus 10k. Minus 1 and minus 9. I'm doing something wrong here. That's minus 9. Minus 5 plus j. Sorry, it was minus 5 plus j and minus 9k. Sorry, I made mistake. So -1 and +5 is going to be 4. Yes, I'm sorry. This is not 6. It is 4. Let me write it again properly. Okay. So 5 minus 1 is 4. 4i minus 2, and this is plus 8, right? Because minus minus plus 9 minus 1. Okay, so this is plus 8. I'm sorry, I was a bit confused here. Okay, so this is AC vector. Okay, from A to C, this vector is this one. Okay, now since it is the mirror image, so the distance between AC is the same as CB. Okay, and this vector, of course, I can put it anywhere. So AC vector is same as CB vector. Okay, so this is same as CB vector. Okay, so you can see that OB vector from position vector from the origin to B vector, right? So if I say OC plus CB, right? OC plus CB is equal to OB vector. Okay, so from here, yes, so it means OB vector is going to be OC. And what is OC? OC is the same thing as the position vector of C, and which is, I wrote it here as well, it is minus I minus J minus K. So this is OC, okay, plus CB. This is OC, and CB I already wrote here. It was 4I minus 2J and plus 8K. So -1 plus 4, it is 3I, and minus J minus 2, this is minus 3J, and minus K and plus 8 plus 7K. Okay. Uh, so the position vector of B is 3I minus 3J minus 7K. Yes. Okay. So the position vector of point B, which is mirror image of point A in the line L2 on line L1, is given by this thing. Okay. I hope you understand all the logic and all the reasoning of what I'm doing this thing. Okay. This is important to understand. It was an interesting question. Okay. So you try to understand all the logic behind it. Okay, now this next question from calculus. Given that 2x is equal to tangent y, show that dy by dx is this thing. Okay, so there are two ways to do it. Let me do it a bit non-traditional way. So from here you can see that x is equal to 1 by 2 into tangent of y, right? X is equal to 1 by 2 tangent of y. Okay, so can I do dx by dy? Normally we do dy by dx, but now I'm differentiating x with respect to y. Okay, so you know that tangent x derivative is secant square x. So tangent y derivative is secant square y. Okay, easy. Okay, and then from here I can say that dy by dx, if I take the reciprocal on both sides, dy by dx, that is going to be 2 over secant square y. Okay, but remember, sine square x plus cos square x equals 1. If I divide the whole expression by cos square x, so sine over cos will become tangent square x plus cos over cos is 1, and 1 over cos is secant square x, right? So as you memorize this expression, sine square plus cos square is equal to 1, you should know this one as well. Tangent square plus 1 is equal to secant square x. Okay, so from here, the secant square y can be replaced by 1 plus tangent square y. Okay, 1 plus tangent square y, and If you remember what was the given expression, yeah, this one or this one. Okay, so tangent square y, from here you can see that tangent square y would be equal to 4x squared. If I take 2 on the other side, or well, let's see from here, if I make the square on both sides, so tangent square y is 4x squared. So let's substitute this here. So this will become 2 over 1 plus, and this is 4x squared. Okay, so this is what we need to show, that dy by dx is equal to 2 over 1 plus 4x squared. Okay, so this part was easy. Now let's move on to the next part. Hence, find the exact value of this integral. Okay, this is a bit involved. Okay, uh, I will do integration by parts here. Okay, so this will be equal to uh, first function is tangent inverse 2x into integral of the second function. I'm calling this part as my first function, and this is my second function. Okay, so first function into integral second function, x integral is x squared by 2 minus integral of the second function, so x squared by 2 into derivative of the first function. Okay, now how can you find the derivative of uh, this one? Uh, yes, what did we do over here? Hmm, you see, this thing uh, that tangent inverse 2x, if I call it something y, for example, so 2x is equal to tangent of y. Okay, so this part is same as this one. Okay, and from here we know the derivative is this part. Okay, so it means that um, minus so the derivative of this part, from here I want to find I need to find the dy by dx, and that is going to be 2 over 1 plus 4x squared into dx. Okay, I don't know if I have been, okay, and this will have limits, of course. So this part has limits 1 by 2 to 3 under root by 2, and this also has the same limit 1 by 2 to 3 under root by 2. Okay. Uh, it looks like I'm confusing you guys. So first function into integral, second function minus integral second into derivative of first function. Okay, so basically, if I have this thing t, let's say t is equal to tangent inverse 2x, right? And if I need to differentiate it, I'm trying to find derivative of t with respect to x, right? So I know that the derivative of this part, uh, my goodness, no, this is not the way to explain, I'm sorry. Uh, okay, yeah, this I want to find out, for example, right? So if it is y, and I'm to find that I'm trying to find the dy by dx. Okay, so this is same as tangent of y is equal to 2x. The same thing here. Okay, so from here I'm trying to find dy by dx, so which I only found over here. So basically, integrating this part, right? Sorry, finding the derivative of this part is same as finding the derivative of this part, which we did over here. Okay. Anyway, try to understand this thing. I know that I'm a bit confusing over here, but try to understand this part. Okay, so this is equal to, let me put the limits over here. When I put upper limit, it will become tangent inverse and 2x. 2x mean 2 times this upper limit will become under root 3 only. Okay, into x squared by 2. So this is one part, and then 1 by 2 into x squared. So x squared will be 3 by 4. Okay, so this is upper limit. Minus, when I put the lower limit, it will become tangent inverse, and 2x mean 2 times 1 by 2. So this is 1 only. Okay, so this is one thing, into x squared by 2. So 1 by 2 into x squared will be 1 over 4. Okay, minus, here 2 cancels with 2, and I have x squared over 1 plus 4 x squared dx, and limit 1 by 2 and under root 3 by 2 here. Okay. Uh, you see here what I need to do, I will use the long division and try to simplify this thing, but let me do it in the next step. Okay, what is tangent inverse under root 3? You remember, if I have a triangle with angle, this is 90 degree and this is 60 degree. So this is 1, 2, and this is square root of 3. And the tangent of 60 degree is 3 under root, right? So tangent of 60 degree is under root 3. So it means tangent inverse of 300 is 60 degree. So this is going to be 60 degree. 60 degree means pi by 3 into 3 by 8. Okay, minus. Now tangent inverse 1 is 45 degree. 45 degree means pi by 4 into 1 by 8 minus. Okay, now if I'll do this thing through long division, 1 plus 4x squared is outside and inside is simply x squared, because I don't want the degree of the numerator same as degree of denominator. It should be less than the denominator. Okay, so it will be 1 by 4, and multiplying this, it will give you x squared and plus 1 by 4. When I subtract, plus minus, this will cancel, and minus 1 by 4. So that means this fraction can be written as 1 by 4 minus 1 by 4 over 1 plus 4x squared. And this whole thing as dx, and limits 1 by 2 to under root 3 by 2. Okay, I hope it's clear. Okay, so this will cancel here and will be pi by 8 minus pi by 32. Okay, this will be minus 1 by 4 dx, and again minus minus plus 1 by 4, and dx over 1 plus 4x squared, and both have limit 1 by 2 to under root 3 by 2, under root 3 by 2, and 1 by 2. Okay, I hope you are following me and I'm not confusing you. Okay, this part, pi by 8 minus pi by 32. Uh, what, how did I simplify it? Yes, it's 3 pi by 32. So this became 3 pi by 32. Okay, and then I have minus 1 by 4, and it is x, and limits 1 by 2 and under root 3 by 2. Okay. Okay. Plus. There was a 2 somewhere. Mm, Mm. You remember we saw over here that, yes, 2 over 1 plus 4x square. Okay, that was the complete derivative. 2 over 1 plus 4x square. So I want to bring it in that shape. So 2 over 1 plus 4x square. So if I multiply by 2, I do have to divide and it will become 1 by 8. Okay, so I have plus 1 by 8. Now this whole thing, that's what the derivative of this thing, right? Or uh, if I have x, um, or let me write this down, y is equal to tangent inverse 2x, right? So if y is equal to this thing, then the dy by dx is this one. Okay, so now I have dy by dx, I have it. So if I take the integral, it will become tangent inverse 2x. Okay, yes, so 1 by 8, and then its integral will be tangent inverse 2x, and again I put the limits as 1 by 2 and under root 3 by 2. Okay. Okay. So next it is 3 pi by 32 minus 1 by 4. And when I put upper limit, it is 3 in the root by 2 minus lower limit is 1 by 2 plus 1 by 8. Now, when I put upper limit, it is tangent inverse and again under root 3 only, and minus when I put a lower limit, it is tangent inverse 1. Okay, so 3 pi by 32 minus 1 by 8. Okay, if I take 2 outside, and inside I have 3 under root minus 1. Okay, plus 1 by 8. Now, this will give me 60 degree, which is pi by 3. And this will give me 45 degree, which is pi by 4. Okay, so we finished the integration and just try to do the simplification. Uh, 3 pi by 3 minus pi by 4 will give me pi by 12, right? Uh, so where did I do this thing? Okay, and pi by 2 combined with this part, it will give me, oh my goodness. Let me do it again, then I solved it some, but yes, okay, I have it in. It gives me 5 pi by 48. Okay, this time 1 over 8 times this will give me 5 pi by 48. And then I have plus 1 by 8 minus 1 by 8 times minus 1 is plus 1 by 8 and minus under root 3 by 8. Okay, so these are the 3 terms I will get in the exact solution of this integration. Okay, I'm sorry I was a bit confused. So maybe you have some places where you may not understand the whole solution completely, but try to look into this thing and you will understand, I hope. Okay, now the last question is this one, question number 11. Okay, so let's do this question number 11. In a field, there are 300 plants of a certain species, all of which can be infected by a particular disease at time t after the first plant is infected. There are X infected plants. The rate of change of X is proportional to the product of the number of plants infected and number of plants not affected. The variable X and T are treated as continuous. Okay. And it is given as yes, dy by dt, dx by dt, this, okay. Show that X and T satisfy the differential equation, this one. Okay, so we are given this is the rate of change of x with respect to time, of course. So dx by dt, it is proportional to two things, to number of plants infected and number of plants infected with their x, right? And the product of this thing and the number of plants which are not infected. So there are total 300 plants. So plants which are not infected at any point, they are 300 minus x. Make sense? So this the rate of change is proportional to this thing. So if I make it inequality, then dx by dt would be some constant k into x into 300 minus x. Is it clear? Okay. Now show that, okay, we are given that the derivative was zero point 0.2 at x is equal to 1 and t is equal to 0. So this derivative was 0 0.2 when x was 1. So x is 1 and 300 minus 1 is 299. So times 299. So from here I learned that the value of k is 0 0.2 over 299. Okay. So from here you can see that dx by dt is equal to x into 300 minus x, and this k, if I bring it on this side, it will become 1 over k, right? And 1 over k is 299 over zero point 0.2, and this comes out to be, let me do it again, I did it before, but 299 divided by zero point 0.2, it is 1495. 1495, and that's a number over here. So 1495 times dx by dt is equal to x times 300 minus x. Okay, so this is what they asked us to prove that. Okay, so this is my differential equation. Now next part is using partial fractions, solve the differential equation and obtain an expression for t in terms of a single logarithm. Okay, so now I need to solve this. I need to do the partial fraction and solve this equation. Do you agree that dx by dt, okay, this is equal to x into 300 minus x over 1495, or dt by dx, if I take the reciprocal, is 1495 divided by x into 300 minus x, right? So let me do let me expand it in partial fraction. So I will do it a over x plus b over 300 minus x. So from here you can see that 1495 is equal to a times 300 minus x plus b times x only. Okay, so if I put x equal to 0, I will have 1495 equals 300a. So a is equal to 1495 over 300. Similarly, if I put x equal to 300, I will have 1495 equals x is 300, so this is gone. So this is 300 into b. So again, b has the same value, 1495 over 300. So from here, I learned that this equation, I will write this expression again, that dt by dx is equal to a over, so since a and b are constants are the same, I can take them outside, and they are 1495 over 300 and into 1 over x plus 1 over 300 minus x. Okay. Okay. And now I am in the position of finding the integral of this one. So dt is equal to 1495 over 300 into dx by x and plus 1 over, sorry, dx over 300 minus x. Okay. And now if I integrate it on from both sides, uh, it will become t on the left side, 1495 over 300. Here I will have log x, right? And the derivative of this part is minus dx. So I put negative here and negative here. So it is negative, and now it, since the denominator is derivative in the numerator, the answer is log of 300 minus x. Okay, makes sense. And since it is uh, not an indefinite integral, I will have a constant of integration as well. Okay, so let's try to simplify this whole thing. It is going to be t equals 1495 over 300, and this will be log of x over 300 minus x plus a constant of integration. Okay, uh, what can we do now? Why am I writing? Okay, yes, this 1495 over 300, I think 1495 divided by 300, it can be simplified as 299 over 60. So this is 299 over 60 log of x over 300 minus x plus a constant of integration. Okay, how can we find this constant of integration? I remember this condition was given to us that when time is 0, x is 1 and dy by dx is 0.2, dx by dt is 0.2. So when t is 0, x is 1. When t is 0, x is 1. Okay, so when t is 0, so 299 over 60 log x is 1. So this is 1 over 299 plus c. Make sense? So from here you can see that c is equal to, if I take everything on the other side, it will be negative 299 over 60 into log of 299. Log 299, sorry. So remember this negative will make it opposite. So it will become 299 over 60 into log of 299. Okay. So this is my constant c. I can put it here. So t is equal to 299 over 60 into log of x over 300 minus x and plus c. So plus this c is 299 over 60 into log of 299. Make sense? So far so good? Okay, so if I take this 299 over 60 common outside from here and here, I will have log of x over 300 minus x and plus log of 299. And I can join them together like 299 over 60 log of 299x over 300 minus x. Okay, so this was my final answer. I found t as a function of x here. Okay, to obtain an expression for t in terms of the single x. Okay, okay, so this is part B. Yeah, this is the end of this paper. Okay, I hope you understand everything here. Try to understand the logic behind each step. Okay, this question number 11 was pretty straightforward, I would say. The question number 10b, it was a bit confusing. Okay, I tried to explain, but if I'm still afraid that you're a bit confused about it. Anyway, thank you very much for watching my channel. So if these videos are, if you find these videos to be helpful, then please subscribe my channel. That will be your help for me. Thank you very much for watching. See you in the next video.